for this question, we're now working with quadratic functions, which are parabolas in this case. We see that we're asked to identify the vertex, the axis of symmetry, and the domain. Now, the vertex is either going to be a maximum or a minimum, and whether it's a maximum or a minimum depends upon this initial value here, this value of a. If a is positive, greater than 0, the parabola will be smiling, positive, smiling, and the vertex would actually be a minimum. If a is less than 0 or negative, that means the parabola is frowning, negative, frowning, which means that our vertex here is actually going to be a maximum. And the coordinates of our vertex are found through the points h, k, or the values of h and k will give us our vertex. And the axis of symmetry is just the vertical line through the vertex. So the vertical line will be x equals whatever the x-coordinate of our vertex is. And then domain, well, the domain we know is always all reals. And the symbol for all reals is a double bar R. As far as the vertex here, well, the vertex is pretty easy to identify. We know since this value is positive that the parabola is smiling and our vertex will be a minimum. And our values of h and k are right here. You might say, well, I see a +4. Well, that actually means that the vertex is -4, and then the y-coordinate of the vertex is -1. So you need to be careful of the sign here in the parentheses. Realize that that +4 is really minus a -4. So this is our vertex, and then the axis of symmetry will be the equation of the vertical line through the point -4, -1. And back on question number 5, we learned how to write equations of vertical lines. The equation of the vertical line, and in this case, the equation for the axis of symmetry, is just going to be x equals the x-coordinate of the vertex.